I will be explaining the concept of the determinant of a matrix. Given a square matrix, let's call it A, we denote as A sub ij the matrix obtained by removing the row I and column j of matrix A. So we have a matrix and we are defining a new matrix that will be obtained removing, if we put as a subindex ij, then we are going to be removing the row I and the column j. So, for example, if we have this matrix, this is the matrix A, and I want to obtain the matrix A sub 1, 1. So will be a matrix in which we remove the row 1 and the column 1. So it will be a matrix in which remove this row and this column. So obviously if we do that, we are going to obtain a 2 by 2 matrix. So if we have a 3 by 3 matrix, finding A sub ij will be finding a 2 by 2 matrix. So it will be a matrix that have one row and one column less. So in this case will be this matrix 0, -5, 14, -6. So this will be the matrix A sub 1, 1. We are using the same letter, capital, and here we are writing the row and the column that we are removing. With the same matrix, what will be A sub 2, 2? It will be another matrix in which we remove the row 2, so this row, second row, and the second column. And obviously, if we do that, we are going to obtain a matrix with the elements of the entries -1, 7, 4, and -6. So that will be the matrix A sub 2, 2. Or what happens if I ask you what is the A sub 3, 2? A sub 3, 2 will be the matrix in which we remove the row 3 and the column 2 of matrix A. So in this case we obtain the matrix -1, 7, 12, and -5. So this will be the matrix A sub 3, 2. This will be important to define the concept of determinant. So we are going to use this matrix to find the determinant of this A. So now we are ready to define what is the determinant of a matrix. So the determinant of a matrix will be a rule, okay, will be a function that assigns a real number to every square matrix. So we need to have a square matrix first. So the number of rows and number of columns need to be the same. And second, when we make the assignation to the matrix, what we are going to assign will be a number. So will be an assignation of a real number to a matrix. When we say function, a function is a rule that assigns something to the elements of one set. In this case, we have the set of all the square matrices, and for each square matrices, we are going to find a real number that we also call the determinant of the matrix. But initially, the determinant of a matrix will be a rule. So defining determinant is defining this rule, this function. So if A is an n by n matrix, obviously it needs to be a square matrix, so the number of rows and the number of columns need to be the same number. I'm going to call it n. Then the determinant of A is denoted, so I'm going to tell you first how I'm going to denote the determinant of the matrix. I'm going to use this det, D-E-T of A. Okay, well, I'm going to use a definition that we call it in mathematics, also in logic and in computer science, we call it a recursive definition. So I'm going to define this in this way. First, I'm going to define what happens if n is 1. If n is 1, so it will be a 1 by 1 matrix. Then the determinant of A will be the same A. So it will be very easy. If we have that the matrix is very small, the smallest possible matrix, they have only one element. So this element is the determinant. So the matrix is just a real number. In other words, if we have this is the matrix A, then this is the only element A. Whatever number here, could be 7, could be 8. The determinant of this, it will be just A. So the determinant of A will be A. We have defined the determinant of only one type of matrix. If n is greater than 1, the determinant of A can be computed as follows. Now you're going to see why was important this definition at the beginning. First, choose any natural number, I less or equal than n. For example, if n equals 2, then I could be 1 or 2. Remember, natural numbers. We're starting natural number from 1. So if n equals 3, we choose or maybe 1 or 2 or 3. But the number that you choose need to be less or equal than n. So that actually means, or it have the same meaning of choosing a row, because if I choose number 1, I can say I'm choosing row 1. So actually this is what I'm thinking, I'm choosing a row. Then the determinant of A will be given by minus 1 to the power I plus 1 multiplied by A sub I1, and this multiplied by the determinant of this matrix A sub I1. Observe what is everything. This A sub I1 is the first element in the row I, the row that I have choose. I choose I, remember. This minus 1 is to the power I plus 1. Again, here appears the same I. And this multiplied by the determinant of the matrix in which I have deleted the row I and the column 1. We have defined this before, but this is not the only term. Now I need to add plus minus 1, again I plus 2. So the power now is I plus 2. First, in the first term was I plus 1, now it's I plus 2. Multiplied by A sub I2, that this is the second term in the row I. Multiplied by the determinant of the matrix in which I have eliminated from A the row I again, but now the column 2. And we continue, and we are going to add plus minus 1 multiplied by I plus 3. Now it's 3. And now we multiply by the third term of this row I, and multiply by the determinant of the matrix in we have again eliminated the row I, but now the column 3. So it's a lot of work, because we are going to continue in this row in this way, in such a way that we are finished with the last term of this column A sub in, when we raise minus 1 to the power I plus n, and we multiply by the determinant of the matrix in which we eliminate the row I and the column n. You should observe that this minus 1 raised to a power define just a negative or positive signs of each of the term. For example, if this I is 1, when I add 1 plus 1, the exponent will be an even number, and then this will be minus 1 to the power an even number. It's always a positive 1. So this multiplication is just giving a sign to the term. For example, if I is in such a way that the exponent is an odd number, then minus 1 to this odd number will be negative 1. And this negative 1, what it's going to do is just give a negative sign to this term. So this power of minus 1 is just defining the sign of the term. And it will be an alternation, because you just notice the even and odd numbers will be alternating. And then will be positive or negative signs alternating in this expression. Something that you can ask me now is, you are defining determinant. How you are using the word determinant in the definition? That is a good question. This is a type of recursive definition. So we define the determinant of a 1 by 1 matrix when n equal 1. So if you use this definition, you can find the determinant of a 2 by 2 matrix, because anytime that you cancel one row and one column of a matrix, if the matrix is a 2 by 2 matrix, then this matrix A sub I1, for example, it will be a 1 by 1 matrix, and we know what is the determinant of a 1 by 1 matrix. So this is good because with this definition you can now compute every determinant of a 2 by 2 matrix, and also a 3 by 3, because now you know how to compute the determinant of a 2 by 2 matrix. If you want to compute the determinant of a 3 by 3 matrix, so when you make eliminations of rows and columns, what you are going to obtain is 2 by 2 matrices. And then, as I told you, you already know how to compute these determinants. And now you know how to compute the determinant of a 3 by 3 matrix. Because you know how to compute the determinant of a 3 by 3 matrix, now you will also know how to compute the determinant of a 4 by 4 matrix, and so on. So you can, with this definition, find the determinant of whatever matrix. Let's see how will be the computation of the determinant. For example, if you have a big matrix like this, whatever matrix of n by n matrix, this number will be whatever number. A sub 1, 1, remember, is the element that is in the row 1, column 1. For example, in this will be minus 1. A sub 1, 2 will be the element in the first row, second column. A sub n 2, for example, will be the elements in the row n and column 2, etc. If I need to find the determinant of this, the first thing I'm going to do is choose a row, choose an I, choose row 1, for example. If you choose row 1, then the definition will be this I will be 1. So it will be 1 plus 1 equal 2. So it will be minus 1 to the power 2. Here will be A sub 1, 1. And here will be the determinant of A sub 1, 1. The determinant of the matrix that you obtain when you remove row 1, column 1. So let's do it. So the determinant of A will be minus 1, 1 plus 1, A sub 1, 1. And then eliminate row 1, column 1, and you obtain this matrix here. So we have this matrix. Second, you got the second element of the same row 1. So this A1, 2. Then you plus minus 1 to the power 1 plus 2. This minus 1 to the power 1 plus 2 will be minus 1 to the power 3. But minus 1 to the power 3 is negative 1. So what I'm telling you is that the second term is negative, just that. And you type A12, this number, A12, and multiply by the determinant of the matrix that you obtain when you eliminate row 1, column, and you see the matrix that you obtain, A sub 2, 1, A sub 2, n, and all the entries that you can have in the remaining matrix. So it will be this matrix, A2, 1, 1, A2, n, 1, etc. And you continue doing the same, then the third element, the fourth element, until the last one. So let's put it here some points. Plus minus 1 to the power 1 plus n. So this depends on n. If n is 5, this number is even. 1 plus 5, 6. Negative 1 to the power 6 will be positive 1. So this will be a positive number. A sub 1n, that is this element. And then you are going to remove row 1 and column. So you are going to obtain this matrix. The remaining matrix is the one that you need to compute the determinant. But these determinants could be big if n equal 5 or n equal 10, for example. What you are going to do is just for each of these determinants, you need to do the same. So actually, if you are actually computing this by hand, you have a lot of work. For sure, we are not going to do it by hand, but a computer can do it for you. Okay, so that's the way that we compute the determinant. Let's make an actual problem. And obviously, we have time to make a 2 by 2 matrix. If we have a 2 by 2 matrix, Let's say, for example, if we have this matrix A, B, C, D, 2 rows, 2 columns. What to do if you want to compute the determinant of this matrix? Again, I can use the formula. So choose row 1, for example, could be any other row, whatever row works. It can be proved that the answer is the same if you choose a different row. The determinant of A will be minus 1, I equal 1, and then will be 1 plus 1, minus 1 to the power 2. A, this is the element that is in the first row, first column, multiply by the determinant of the matrix that you obtain removing the first row, the first column. This matrix will be just the matrix D, the matrix that have only this element D. So it will be the determinant. And this determinant is very easy. So you don't know how to compute the determinant of 2 by 2, but this formula tells you how to compute it, because what you need to do is actually compute the determinant of a 1 by 1 matrix. Oh, we haven't finished. There are another term, because there are 2 elements in this row. So it will be plus minus 1 to the power 1 plus 2 multiplied by B, that is the element, A sub I2. Observe that I'm using this formula here until this part, yeah, because n equals 2. So we type A sub I2, in this case is A sub 1, 2. And A sub 1, 2 is B. Multiply by the determinant of the matrix obtained by removing row 1, let's remove row 1 and column 2. So this matrix C. So this is, and we are done. So this is the determinant of A, but let's simplify this. For example, here is minus 1 to the power 2. This is positive 1 multiplied by A. This is just positive A. So A multiplied by the determinant of this matrix, but the determinant of this matrix is D. So multiply by D. Then here is minus 1 to the power 3. Minus 1 to the power 3, you notice that is negative 1. So it will be minus B, this is the number B, multiplied by the determinant of C. And the determinant of this matrix C is just C. AD minus BC. We have found a formula. Whatever 2 by 2 matrix is in this way. So we have found a formula that help me to find the determinant of any 2 by 2 matrix. So it will be just multiplying the first element multiplied by the element in the same diagonal, AD, minus, that is a minus sign, and this minus sign is because this minus 1 to the power 3, minus the product of the elements in the other diagonal, BC minus BC. So we can type this formula. Anytime that I have a 2 by 2 matrix, I can do this. The determinant of the 2 by 2 matrix is the product of the diagonal, the main diagonal we call it, minus the product of the other diagonal, BC. And then we can solve some problem like this. For example, what will be the determinant of this matrix? It will be very easy. Yeah? So it will be the determinant of B will be 2 times 3 minus 4 times 1. And this is 6, and this is positive 4, yeah? minus 4, it will be positive 4. So it will be 6 plus 4, and this is 10. So compute the determinant 2 by 2 matrix. It will be maybe faster doing by hand than using a computer. Or for example, if we have this matrix, find the determinant of C. So the determinant of C will be minus 3 times 0 minus 8 times 7. So it will be minus 3 times 0 minus 7 times 8. And this will be 0 times 3, negative 3 times 0, 0, minus 7 times 8, so minus 56. And that's the way that we compute a determinant of a 2 by 2 matrix. Now that we know how to compute a determinant of a 2 by 2 matrix, we can learn how to make a determinant of a 3 by 3 matrix. Let's do it. If A is like this, whatever matrix, A, B, C, D, E, F, G, H, I. And to make this, I need to choose one I. The I that I'm choosing is I equal 1. But you should do it choosing a row 2, for example, and you notice that the answer will be the same. So the determinant of A will be, remember, look at this, minus 1, 1 plus 1, because I'm choosing I equal 1. So minus 1 to the power 1 plus 1. A, that is the element, A should 1 element, so the element that is in the first row, first column, multiplied by the determinant of the matrix that result of eliminating the first row and the first column. So it will be EFHI. And we know, because we solved it in the previous example, how to compute this determinant, the 2 by 2 matrix. Now, using the formula minus 1 to the power 1 plus 2, so minus 1 to the power 3. So it will be minus 1 to the power 1 plus 2, and then the element, the second element of this row, that is B, and the matrix that result of eliminating first row, second column. It will be D, F, G, I. Plus, and now we are going to be in the third element of the same row. So it will be C, but minus 1 to the power 1 plus 3. Yeah? The first row, third column, minus 1 to the power 1 plus 3. This is C, multiplied by the matrix that resolves eliminating first row, third column. It will be D, E, G, H, the matrix. And we can compute this determinant easily. It's a 2 by 2 matrix. Let's do that. This is a positive number. Minus 1 to the power 2 is plus 1. So this first term is positive. So I'm going to type A. And this determinant is EIHF. So this will be A multiplied by EI minus 8F. Remember, in the previous slide, I was explaining how to compute determine a 2 by 2 matrix. Here will be minus 1 to the power 3. Minus 1 times minus 1 times minus 1. The answer is minus 1. So it's negative. So this term is negative, minus B DIFG. And this term will be positive. You see that? It will be alternating. Minus 1 to the power 4. Minus 1 to the even power is a positive number. So it will be positive 1. Positive 1 multiplied by C is just C. C that multiply DH minus EG. And we have a formula. But this formula is difficult to remember. Let's try to simplify this. We can make the multiplications first. AEI minus AHF. Then minus BBI plus BGF. And finally here will be plus CDH minus CEG. And one idea is just type first the positive number AEI plus BFG plus CDH, and then the terms that are negative. So we can have this formula. The determinant of a 3 by 3 matrix like this, it will be difficult to remember this formula. We can have it beside us, but it will be difficult to remember in case we don't have it at hand. So a good idea to have the formula that people use when you have a matrix, a 3 by 3 matrix, a good idea is to repeat the two first columns on the right side of the matrix. So for example, if you have this matrix A, B, C, D, E, F, G, H, I, you can type here A, D, G beside the matrix, A, D, G, then B, E, F. So repeating the two first columns. Some people repeat the two first row, for example. Here, because I have better space here, I'm repeating the two first columns. And it will be easy to remember. The diagonals that are downward diagonals, AEI, are positive, AEI. BFG, and here CDH. So multiply the numbers in the full downward diagonals and put it positive is what you need to do. So it will be AEI, BFG, CDH. And you notice that they are the same terms that are positive here. So it will be AEI plus BFG plus CDH. And then the others the upward diagonals GEC, you see here, negative GEC, HFA, you see here HFA, so it will be minus, then multiply the numbers in the full upward diagonals, and this product will be negative. So all this diagonal here, minus GEC, minus HFA, minus IDB. And that gives you how to compute a determinant of a 3 by 3 matrix. For example, if you have this matrix, and I need to find the determinant of this matrix, then I repeat the two first columns of the matrix. So the determinant of A will be multiplying the downward diagonals. I'm going to see the full downward diagonals. So it will be minus 1 times 0 times negative 6. You can type what is the answer. Negative 1, 0, negative 6. For example, this is for sure 0. And this will be 2 minus 5, 4. That is negative 40. And then 7, 12, 14. And this will be positive. And now the minus all the upward, the full upward diagonals. This one here for 0, 7, 14, minus 7, minus 1, minus 6, 12, 2. And type it as a negative product. So the first one will be 0. This will be 40, negative 40. This is 7 times 12 times 14. Use your calculator for doing. I obtain 1176. This term here is 0 again. If one factor is 0, so all the product will be 0. When you multiply these three numbers, you're going to obtain a negative number here. It will be 14 times 5 equal negative 70. Negative 70, and this term here will be positive. So it will be negative 70 plus 144. Use your calculator to obtain this. I obtain 1210. So we have assigned a number to this matrix, to the original matrix, and this is the determinant of the matrix. And the determinant of the matrix, in this case, will be 1210. I believe that for computing a 3 by 3 matrix, if I have this problem, I will be using a computer. I will be using a software. And we are going to see how to solve a problem like this using first Excel. Of course, Excel is not the only software that can help us compute determinant. But let's start with Excel. Let's see how to compute the determinant of a matrix in Excel. In Excel, the function that we are going to use to compute the determinant of a matrix is this. It's easy to remember. You have an M and then the first letters for determinant until the M. And if you have an Excel spreadsheet with a matrix, for example, in this case, we have this minus 1, 2, 7, 12, 0, minus 5, 4, 14, negative 6, a 3 by 3 matrix. And I want to compute the determinant. Choose whatever cell of Excel. I'm choosing this and type equal this function, and the cell, when you see here the element A sub 1, 1, column, and the cell when appears the last element A sub n, n. And type here equal M determinant A1 C3. So don't forget, open bracket in the argument and close the bracket after the argument. So the argument will be A1, the cell in which you see the element A sub 1, 1 of the matrix. So this is the cell A1. Column and C3, the cell of the element A sub n, n. And press enter. Excel give you the determinant immediately of this matrix. So 1210. I guess that was the same number that we obtained working by hand with this matrix. Whatever matrix, it could be even bigger matrix. For example, this matrix. This is a 1, 2, 3, 4, 5, 6 by 6 matrix. And again, M determinant, don't forget the equal signs at the beginning, and the cell of A sub 1, 1, so this cell A1, and the cells of the last element of the matrix, or just select the matrix. You can type equal M determinant and then choose the matrix, whatever you think that is easier. but then it will, in this one will be A1, F6. Look at the last element of the matrix is in the cell F6. And press enter. You press enter, the matrix, the Excel give you the 326. It will be, so the way that you should work if you have Excel and you need to compute the determinant of a very big matrix. Sometimes results easy to compute the determinant of some matrices, maybe faster than entering the matrix in a software. For example, if you have a triangular matrix. If you have a triangular matrix, like for example this one, this is a 4x4 matrix. It results very easy to compute the determinant working by hand if you choose as the row with more zeros. For example, in this case, the last row. Because in this row, we are going to have products that have a 1 factor 0. The determinant of A will be minus 1 to the power 4 plus 1. A for 1, so the element in the first row, first column, multiplied by the determinant of the matrix that results eliminating the fourth row, first column. Plus minus 1, 4 plus 2, A for 2, determinant of A for 2. Check that we are following just the definition. Plus minus 1, 4 plus 3, A for 3, determinant of A for 3. And finally, choosing the last element, minus 1 to the power 4 plus 4, A for 4, determinant of A for 4. And A for 1 is 0, A for 2 is 0, A for 3 is 0. So, this, when you make this multiplication, all the product will be 0. This product will be 0. This product will be 0, and it will be only one product. That will be the product related to the last element of the row, A for 4. So, since many product will be 0, computing the determinant using a row with many zeros made the computation easier. The last element of the row will be always minus 1 raised to an even number, because will be always 4 times 4 plus 4 if this is a 4 by 4 matrix, or 5 plus 5 if this is a 5 by 5 matrix, etc. So this will be always positive. And now computing the determinant of this, again you can use the technique that we use for computing the determinant of the 3 by 3 matrix. But again, this is a triangular matrix. It will be A33 multiplied by this matrix. So it will be so actually the determinant of the original matrix will be A44, A33, determinant of this matrix. And then again, this is a triangular matrix. This is the determinant of a 2 by 2 matrix, and this will be just the product of the diagonal, the main diagonal, minus the product of the upward diagonal. But this product will be 0, so it will be A1, 1, A2, 2. So the answer will be A44, A33, A22, A11, and we found a very important result. The determinant of a triangular matrix could be upper triangular. You can notice that in a lower triangular will be the same if you choose the I equal 1. So it will be the product of the elements in the main diagonal. So you just multiply this product and you get the determinant. So for example, compute the determinant of the following matrices. The determinant of this matrix. This is a diagonal matrix, but it's also a triangular matrix because all the elements below the diagonals are 0. Or what about this? This is a triangle, a lower triangular matrix, or one like this, an upper triangular matrix. In each case, for example, the determinant of B will be the product 1 times 8 times minus 9 times 4. So I don't need to do all this thing if we have a triangular matrix. So it will be A times 4, 32 times negative 9 equal negative 288. Or for example, this, the determinant of C. The determinant of C will be negative 2 times 5 times 4. multiply the elements in the main diagonal. Minus 2 times 5 times 4. And this is minus 2 times 4 is negative 8 times 5, negative 40. And finally, this is the determinant of the is just 7 times 3, 21. And with this, I finish this video. I hope you find it useful. Thank you.